What's up, guys? Welcome back to Mr. Klotz Math. We are the M3s, and today we're looking at some more trigonometry.
Math week coming up soon.
Really? Well, you running it.
Like and subscribe.
Math week.
Like and subscribe.
David's going to run you some math.
Daily video.
Yeah.
Right, we've just done that question. Hopefully you're all good with it.
Yeah.
What were the difficulties that you're facing at this stage? Nothing? Good. Anyone got some difficulties? Yeah.
Not really difficulty, but I just forgot I put 8 times cos 48/7.
Yeah. Normal things, like I've said, getting who got the hypotenuse and opposite and adjacent wrong slightly to start with. They're just not listening because they're still working. Okay. It does happen. You just have to be careful. Right. I told you last lesson there's one final thing that we need to do before we can really get on and solve all the problems, which is angles. So, for instance, when I got you to do this to start with, when we did our bit of investigation, I asked you to draw a triangle, any triangle, and I actually just asked you to measure these two sides. So let's say this was 15 and this was 12. That's it. Oh, you don't have to just yet. Let's talk it through. All right. What we then knew, well, what I asked you, so you just measured them. I didn't ask you to do any particular angle or anything like that. I just asked you to draw any old triangle and measure the sides. And then I asked you to write down certain ratios. The last thing I asked you to do was, well, measure the angle and then compare that to what the calculator gave you. All right. We're going to use that process to say, right, if I know two sides, I can actually work out the angle. What we're actually going to do is, well, first off, let's use another method to work out what this side is first, just as a bit of practice. What do we do? Okay, so I'll wait for you to do that. Figure out what the third side is using Pythagoras theorem, because those two are linked. Quite often questions are linked between Pythagoras theorem and trigonometry. So now you can draw. So what I'm going to ask you to do now, so we've got a triangle. I gave you the 12 and the 15. We can work out the third side. We wouldn't normally have this much information for a problem like this, but I just wanted to go through a couple of things. Right? First off, what are the ratios that we're normally interested in? We're normally interested in sine of an angle, which is the ratio of
Opposite over
the opposite divided by the hypotenuse. Yes. We're also interested in the cosine of the angle, which is the and we're also interested in the tangent of the angle, which is the
opposite over adjacent.
So obviously there are other ones we could do, but these are the three that give us everything we need. So I just want to, first off, to write down what those would be. So sine of theta is, well, if this is going to be my theta, it would be 12 divided by 15. Cosine of the same angle would be 15 over 19.2. Actually, that's wrong, isn't it? Is that why you were looking at me funny? Yeah, that should be 19.2, shouldn't it? For the hypotenuse. And then tangent. So the tangent of whatever theta is should be the 12 over 15. Okay? So they're my ratios. What do I know about theta in each case? Should it be the same or different? It should be the same. Even though the three ratios are different, it should all lead you to the same triangle, right? Yeah. So what we want to be able to do is, well, if we know the ratio, it should be possible to know what the angle is, because if we know the angle, we can find the ratio. So that's just the opposite, right? So just like dividing is the opposite of multiplication, finding the ratio should be able to be reversed to find the angle. And we can. So what we're going to do, again, we're going to continue to use your calculator. And this time though, we're going to say, well, theta, theta can be found by doing the inverse sign. It's got a sign with a little -1 at the top. It doesn't mean to the power of -1 like other things we've done. It just means we say it the inverse sign of, in this case, 12 divided by 19.2. This one would be theta is the inverse cosine of 15 over 19.2. This one would be theta is equal to the inverse tangent of 12 over 15. So if I did the inverse sine of that, or the inverse cosine, or the inverse tangent, you should get theta as the same answer each time. So all we need to do is use our calculator to find the inverse of those things. Anyone know how to do it?
Yes.
So it's your second function, yeah. And what I would do is I would put it as a division in. Don't do the division and then round it. Just press your inverse sine or inverse cosine button, then put 12 divided by 19.2 and close the brackets.
I did that.
Or can you do it with all three
All
and
three.
check that you do get exactly the same answer? And if you don't, why not?
38.682 for sine.
Exactly the same?
No.
Yeah,
Oh, wait, I did it wrong.
38.624. Very close.
And then
12 over 15. 38.659.
okay. So if I have three possible answers, and you were asked to give one of those for an assessment, they should all be the same, right? They should be, because they all come from the same triangle. So if in an assessment you've got all three options, which ones do you pick?
The average of
The one that you use for the phone.
Eh? We use Socotar, that's what we've done. But we've used all the information I've got. We've done everything, all three of them are fine. There's no mistake in any of them. Alright? Are they all basically the same answer? Yeah? They are slightly different though. Why are they different? Rounding. Where did we round? Yes.
Oh,
Right. Good. We rounded this number here. Didn't we?
Yes.
You rounded it because you had to do some calculation. Look, and 19.2, well, it isn't exactly 19.2, you did round it. So let me ask you again, if you're in an exam and you've got those three options, which one do you choose as
Tangent.
Why?
because any of them, it doesn't have a
No, because it's not right.
I would always, because quite often with a trigonometry hypothesis theorem question, it will be a multi-stage question, and by the time you get to the last part of the question, there are several possible ways to answer it. Okay? And you should always go down, if there are options, always use the information you're given, not the information that you've had to work out. That's because it may have been rounded. It may be that you made a mistake in one of your numbers. So it's better. So this one, in this case, I would definitely go here because it's 12 and 15. Nothing's rounded there. So I would actually go this one 38.7 degrees, rounded. Well, that one would give me exactly the same answer anyway. This one, slightly off, but still, it's very close. So we've still got the fact that the answer is there. That situation, by the way, is only if you've got enough information to pick whichever ratio you want. I'll just ask you to do something for me. Just pick the tangent one. What happens if we accidentally get things the wrong way around? Can you try it for me?
Oh, that is not saucy McBossy.
Right, before you dismiss that too much, I want you to tell me, what is that significant of? Was it 50?
51.34.
51.3. Okay. Do you notice anything?
Yeah.
It's different from the other number.
It is different, but do you notice anything? If you notice it, you're super smart and very. That's not a problem. Who's the most observant? I'm going to put. If the adjacent and opposite have been swapped around, is it wrong, or have I looked at something different in the triangle?
It looked at something different. The other end.
Yes, there you go.
Oh my.
Right? If I say this one's the adjacent by mistake and this one's the opposite, well, which one is it adjacent and opposite to?
The angle on the
This
top
one.
right. Oh,
Now,
darn.
does that work?
Yeah.
7.6. Is it?
38.
38.6.
And then 51.
Why does it
Three.
work?
So then it'll be 38.6.
So what did we say this one? 38.7.
It's 179.
And this was 51.3. Add those together to me. What do you get?
179.9. Yeah.
You added
Why don't you get 180?
Because we rounded.
Rounding again. Yeah. But yeah, if you get those two the wrong way round, you get the other angle, which is actually super important to understand because it'll look right.
Yeah.
Because you found one of the angles in the triangle. Right? There's no problem with that, right? You just you'll find it very difficult to spot a mistake. On the contrary, though, what if you did these two the wrong way round? So do this one, for instance. Have a go at do theta is the inverse sine of 19.2 over 12, and tell me what you get.
Domain error. Yeah, that's what I
Why?
Because
It's not possible.
Why not?
Because
it's the right angle.
Said so.
Not just because it's the right
Our
angle.
hypotenuse needs to be the longest.
There you go. This ratio is opposite over hypotenuse. If I get the wrong way round, it's not possible to have that as a triangle because I can't have the opposite side being longer than the hypotenuse. Alright? That's why this one, the tangent, opposite and adjacent, that's fine. They can be whatever they can be. Alright? But the sine and the confirm the cosine one, same issue. Do you get a domain error with the cosine one as well?
yeah.
So that's always,
Domain error.
yeah,
I got
that's
domain error.
that's always the thing. If you make a mistake with sine or cosine, if you get things the wrong way round, if you get the opposite and adjacent wrong, you're not going to know from that. But if you get the ratio the wrong way up, you will at least get an error on your calculator. Alright, which is nice to know. Alright. But tangent, no check. Alright, couple of questions? Alright, let's work out some angles. So, let me pause. Alright, solve for theta in each case. with this one,
Opposite is 7.
I would be going again. We should be doing SOHCA.
Oh wow.
SOA. It's always the same thing. Theta, opposite, adjacent, hypotenuse. Theta is theta, right? 15 is the hypotenuse. 7 is the opposite. Don't need an adjacent, so those two are gone. So I'm looking at sine theta this time equals opposite over hypotenuse, so 7 over 15. So therefore theta is the inverse sine of 7 over 15. Now again, this is, if your calculator is in the wrong mode, if it's not in degrees mode, you'll get a very silly answer.